Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome again to this TV learning program. As usual, I'm Teacher Pasco, your chemistry teacher. Today, I will be with Senior 2 students, Unit number 7, the mole concept and gas laws. And today, we will have the exercises. We will try some exercises about what we have been discussing. Remember, we discussed the calculation of moles, the relationship between moles and mass, the molar mass, calculation of the empirical formula or determination of the empirical formula, molecular formula, and the calculation of percentage composition by mass. And today we shall have a look at some examples how we work out those calculations involved in this mole concept. So without delaying, let us start with question number 1. How many moles of sodium chloride are present in 117 grams of sodium chloride? I hope you remember the formula we use. How many moles? We are asked to calculate the number of moles of sodium chloride. So how do we get the number of moles? Remember, number of moles, that is for question number 1, N, that is number of moles, is equal to mass over molar mass. So to get this molar mass, that MM, we have to sum up the masses of sodium and chlorine. We read this on the periodic table, and molar mass of sodium chloride will be given by 23 plus 35.5, and we get 78.5 grams per mole. And we go back to the formula. When we substitute, we get 117 grams, let's say 117 grams over 78, no, sorry, here it's a mistake, 20, 30, that is 5, so it's 58.5 grams per mole. And when we work out, what do we get? 117, and 58.5. You can see this will be 2 mole. Okay? So that is how we get the number of moles. Molar mass is needed, and the mass is also needed. And we use the formula mass over molar mass. Number 2, what mass of sodium hydroxide is present in 0.25 mole of sodium hydroxide? Now we are asked to find the mass. But if we use the same formula, we consider the same formula, we can rearrange the formula to get mass. How do we get mass? Mass will be equal to N times molar mass. And we need the molar mass of sodium hydroxide, that is 23 plus 16 plus 1. I'm reading this from the periodic table. You can use your periodic tables to identify or to deduce the molar masses of the elements. You know that, you remember that. So we get 40 grams per mole, and if we substitute, going back in the formula, and we substitute, we get 40 grams per mole times 0.25 mole. And what do we get? We get 10 grams. That is the answer we have. This is the answer we have. Okay? Let me hope everything is clear. So you can use that formula, number of moles, which is equal to mass over molar mass, and you can rearrange it to work out various exercises. Okay? We go to the next part of our exercise. Calculate the total number of atoms in 7.10 grams of chlorine atoms. 7.10 grams of chlorine atoms. So here we are asked to calculate the total number of atoms. How do we get the total number of atoms? We know the number of atoms in, here we are saying, let me use the laser pointer. So calculate the total number of atoms in 7.10 grams of chlorine atoms. To get this, we use Avogadro's number. But the Avogadro's number gives us the number of atoms in 1 mole. So we have to find the number of moles in this mass of chlorine. So how do we get the number of moles? We know that number of moles is equal to mass over molar mass. And if we want to find the number of moles, or let's say what we have here is the mass of chlorine atoms. Okay? Mass of chlorine atoms. What do we get to find the number of moles? Then we get the mass over molar mass. What is the molar mass of chlorine atoms? Here you have to be very careful. When we say chlorine atoms, it's 35.5. And this should not be confused with 71.0. We have 71 because it is a molecule. And here we have 35 because it is an atom. Of course, you can use any of the two. But if you use this one, what you will get will be the number of moles of atoms. But if you use this one, what you will get will be the number of moles of molecules. And to get the number of moles of atoms, you will have to multiply by 2. Okay? So let's use this value to get an immediate answer. Okay? An immediate answer which doesn't require more steps. So we use 35.5 grams per mole. And what do we get? What are we going to get? Let me take my calculator. And if we use our calculator, what do we get? Using our calc, you can take your calculators and we work it together. So we have 7.1 over 35.5, and here we get 0.2 mole. 0.2 mole, and with 0.2 mole, we can now do what? We can now find the number of atoms. Number of atoms will be given. Number of atoms will be equal to the Avogadro's number times 0.2 mole. Here, the unit can be atoms per mole. And when we use atoms per mole, then the mole and mole will cancel out, and we get what? What we get will be the total number of atoms that will be given by, okay, we have 6.02 times 6, we have 0.2 times 6.022 times 10 power 23, and what we get will be 1.0, it's 1.2 0.04 times 10 power 23 atoms. Okay? So that is how we work it out. We have, if you want to calculate the number of particles, make sure you have you use the Avogadro's number. It is a constant value, okay? And many of the times it is given, so you don't have to cram it. There is no need, okay? And with the Avogadro's number, what you need is to use the number of moles. So some questions may be direct, while others may be indirect. So you should always be able to come up with the decision or the conclusion, whether your question is direct or indirect. If the question is direct, you can use the data to just replace the values, or you substitute the values in the formula. And if the question is indirect, then you have to pass through some other steps to get to the values, the data we will need to use in the final step. So we go to the next question. Use these AR values. We have iron, that is 55.8, hydrogen with 1, oxygen with 16, to calculate the mass of 5 moles of iron 2 hydroxide. Here they are asking to find the mass of 5 moles. And you remember the formula we have. The formula for question number 4, the formula to get this mass is molar mass times number of moles. Do we have molar mass? For the compound we have here, iron 2 hydroxide, we don't have its molar mass. But of course, we can compute it or calculate it if we use the molar masses. AR here means the average masses, okay? The relative atomic mass, the one we read on the periodic table. So how do we get the molar mass of iron 2 hydroxide? We use iron, that is 55.8, plus 4 oxygen and hydrogen, it is 17, but you can see we have 2 of them, then 17 times 2, and we get what? We use our calculator again. Okay? Let me hope you're with me. Okay? So if we use the calc, what we get is this. We have 55.8 plus 17 times 2. And we get 89.8 grams per mole. That is the molar mass of iron 2 hydroxide. And going back to the formula so that we can substitute, what do we get? We have the number of moles, okay? Look here. 5 moles of this compound. So with the number of moles and the molar mass that we have already calculated, what do we get? We get 89.8 grams per mole times 5 mole. And what do we get? We use our calculator again, and if we multiply by 5, we get 449 grams, and that is the final answer, right? This is the molar mass, and this is the mass that 5 moles of this compound will have, okay? Good. So we go to the next question, calculate the percentage by mass of iron in iron 3 oxide. Iron 3 oxide, it's this one. So here you have to be very careful. In senior 1, we have studied how to calculate. how to write the molecular formula of compounds. We also reviewed that in Senior 2, in some units of Senior 2 as exercises and, as exercises mainly. So you should always be able to write the molecular formula of compounds, because whenever you will be given a name like iron 3 oxide and you are not able to identify or to write the formula of that compound, then you can't identify what? You will not be able to identify its molar mass, because you don't have the exact number of atoms in the compound. So you should always be able to write the molecular formula of these compounds. Okay, so you can see that there is a certain relationship between what we are studying today and what has been already covered in Senior 1 and Senior 2, okay? There is a certain relationship, so you don't have to forget what we have already covered. And how do we work this out? Percentage by mass, it's the percentage by mass of iron in the compound. So, first of all, we said, remember we said the percentage by mass is given by the mass of element over total mass of compound and times 100, because the percentage, it means the mass of this element in 100 grams of the compound. And how do we get this? Do we have the total mass of the compound? We have to, because there is no mass given, we have to calculate what? We use the molar mass of the compound. How do we get the molar mass of the compound? Let's say molar mass of iron 3 oxide is equal to 50. Have they given? Yes, it's 55.8 times 2, because we have 2 of them, plus 16 times 3. And what do we get? We use our calculator, and the answer we get will be 55.8 times 2 and plus 16 times 3, and we get 159.6. 159.6 grams per mole. That is the molar mass. And if we apply the formula, the percentage by mass of iron in iron oxide, what do we get? Mass of the element, that is, you have to be very careful here, because we have how many moles of iron in the compound? We have 2 moles of iron in the compound. So the mass of the element should be multiplied by 2. This, the molar mass, we multiply it by 2 because we have 2 atoms of iron in the compound. And then we have 55.8 times 2 over 159.6. And what we get here will be 55.8 times 2, that is 111.6 over 159.6. We divide with 159.6 to get 69.92, and if we multiply with 100, then we get 69.92%, and that is the answer. The percentage of iron in that compound. If we go to the next question, that is question number 6, what do we get? It is said, on analysis, an organic compound gave the following data. We have carbon with 57.82%, hydrogen with 3.6%, and the rest is oxygen. When they say the rest is oxygen, we can determine the value of that oxygen. Remember, when we sum up all percentages, we get 100. So to find the percentage of oxygen, that is number 6, let's find the percentage for oxygen. We get 100 minus the percentages we have, that is 7.82 minus 3.6, and we get the percentage for oxygen. And what will be that? It's 100 minus 57.82 minus 3.6, yeah? 3.6, and we get 38.58. 38.58%. That is for oxygen. Now, with the percentages, remember, we said that these percentages are the masses in a sample of 100 grams. So we can use these masses over the molar mass to find the number of moles. And for carbon, we have 57.82 over 12. We will see what we get. For hydrogen, we have 3.6 over 1, and for oxygen, it's 38.58 over 16. These are masses in 100 grams, and these are molar masses for these elements, okay? And if we use our calculator, what do we get? We have 57.82 over 12. We get 4.8. 4.8, this is small, and here it will be 3.6 small, and here it will be 38.58 over 16. We get 2.4 mole. Do you remember how from this step we can determine the empirical formula? Because there it is said we find the empirical formula. Yeah, I'm very sure you do remember. We divide each of the number of moles by this smaller one. And if we divide for carbon, we get 4.8 over 2.4. See, this is the smaller one. For hydrogen, it's 3.6 over 2.4, and for oxygen, it's 2.4 over 2.4. We get 1, we get 2, and for 3.6 over 2.4, we get 1.5. 1.5. Now here there is something new we have never discussed. We have a decimal value here. How do we deal with this one? Because it's 1.5, then here it's better if we multiply by 2 to remove this. We use whole numbers for the empirical formula. That is times 2, and we get 2, 3, and 4. And the empirical formula here will be C4. This is the empirical formula. C4H3O2. C4H3O2. And the next part of the question is to find the molecular formula. How do we get the molecular formula? You know how we work that out. To find the molecular formula, we have the molecular mass. You take the molecular mass over the molecular mass over the mass of the empirical formula, and then you divide that to get the value of n. When you get the value of n, you can now multiply that value of n with the empirical formula to find the molecular formula itself. Good. So I'm not going to find the molecular formula for you because with the explanations and the empirical formula, you can work it out. And the last question we have here is, when 1.55 grams of phosphorus is completely combusted, 3.55 grams of an oxide of phosphorus is produced. Deduce the empirical formula of this oxide of phosphorus. This is also another type of questions we can have in this part of chemistry, the mole concept. And how do we work this out? You can see here we have the mass of phosphorus. After reaction, what increases to the mass of phosphorus is the mass of oxygen. So we can use this. We have mass of phosphorus, it's 1.55 grams, and mass of oxygen is 3.55 grams minus 1.55 grams, and we get 2 grams, okay? So when you have the mass of the product, you can find the mass of one of the reactants because of what we call the conservation of mass. Matter is neither created nor destroyed, but you can transform it. You know that. So the difference we have between these two values is the oxygen which has been added. Now that we have the mass of phosphorus and mass of oxygen, you can do what? You can find the number of moles for phosphorus that will be given by 1.55 over molar mass of phosphorus. Do we have the molar mass of phosphorus there? It's that one. You can find the number of moles of oxygen, that is 2 over 16. And then with number of moles, you can divide with the smaller number of moles to get the empirical formula. So that is how we can work this out. And before we stop the lesson, today's lesson, let's go through the assignment. Use these AR values, it's for carbon, oxygen, and sodium, to calculate the mass of 0.050 moles of sodium carbonate. It's this one. Calculate the percentage by mass of carbon in ethanol. And a compound of carbon and hydrogen contains this percentage of carbon and 14 hydrogen. Deduce the empirical formula and the molecular formula. Thank you very much. See you next time.